A customer just dropped in this iPad mini 3. He wants the digitizer FVC connector fixed. Now he said he has micro soldering experience and he attempted the repair, but he still cannot get touch to work. He brought it in like this, opened. He also brought in the LCD and digitizer, which we have on the bench there. So let's take a look at the work that he did and if this iPad can be fixed. Anytime we have a prior repair attempt, chances are lower for fixing the device. Right now we do not see the digitizer FEC connector. It's totally gone. Right here. It should look something like this. On the positive side, customer did not knock off any of those components, which is a good thing. Let's clean up this area and solder a new FEC connector. Before we start the repair, I have some good news. We just got our first shipment of flux from AMTECH. This is coming directly from AMTECH and it's the freshest in the market. This is the latest release from AMTECH. I'm going to use this flux on this repair to see how it does. Flux will come in a syringe like this. It's 10 grams. It comes with the plunger and two needle sizes, a smaller one and a bigger one. If we look under the microscope, these are the two needle sizes that will be included with the syringe, the bigger one and the smaller one. So let's use this one here. All we have to do is screw this needle here. And there you go. Let's go ahead and apply this flux here and see how it does. Now the nice thing about this flux compared to the 559 one that we used to use is how easy it is to clean. AMTECH said that they modified this flux in a way where it's easier to clean. I did not have a problem with the 559 that I used to use, but this one is supposedly better. Let's see. I mean, look at how solder flows with this. I currently have the soldering iron at 450. I do not need that much heat. So let's go down to maybe 400. Very good. Now I applied a lot of flux. Let's see how easy it is to clean this flux. Yeah. It's easier to clean. I mean, I just put a little bit of alcohol on this ear swab and flux came right off. Very good, very good. Let's grab a new FEC connector. These connectors will be sold on our website. These are high quality connectors that take a lot of heat. They do not melt easy when you apply hot air to them. And a lot of times I have people asking, how come the connector does not melt when you apply hot air to it? Well, it's for two reasons. You do not want to apply a lot of heat, and the other reason is high quality connector. If you are using a cheap quality connector, it's going to melt as soon as you apply heat to it. But even with high quality connectors, if you apply a lot of heat, it's going to deform and change shape, of course. Let's apply some flux. One thing I want to do quick is cover the battery connector so it doesn't get affected by the heat. Just put a piece of Captain tape over it. Okay, the connector is solid in place. Now we can go over those pins one more time. I do not have to, and we've done it many times on YouTube where we did not have to go over the pins. But of course, someone will complain, how come you did not go over those pins? How come you did not apply more solder onto those pins? It will only take a minute. Let's go ahead and do it. Okay, so that's one side, and let's do the other side. And that's it, the job is done. Clean up. We applied so much flux on this connector, and as soon as we touch alcohol onto the board, look at this. The main difference I noticed is it's not sticky at all. As soon as we apply alcohol onto the board, it wipes right off. One final cleanup. Okay, very good. All we have to do is test and see if touch is working. I thought the customer said iPad mini 3. This is not iPad mini 3. This is iPad mini 1. Customer said it's an iPad mini 3. The same FEC connector will work on all three versions, iPad mini 1, 2, and 3. We need to plug the digitizer first. And let me make sure his digitizer is good. If the pins on it are good. And I don't think so. Okay, it's a good thing I checked. Look at his digitizer. What's this? Okay, now it's good. Okay, so it's connected. We're gonna connect the LCD. Let's check his LCD to make sure it's good also. And the connector doesn't look too good, but what can you do? And we're gonna connect the battery. And let's turn it on. Considering battery is charged. Is it charged? Yes. Okay, what does it say? iPad is disabled. Try again in 1 hour. Great. We're gonna have to try this back in 1 hour. It's disabled. And it's working. 789. I do not want to put the wrong password. 456. Delete. 123. Awesome. We're gonna put this back together, call the customer to come and pick up, and I'll do another device, maybe in this video or some other video. Here I'm working on a Lenovo IdeaPad 330. I thought the camera was on, but it wasn't. So let's take a look at the board. Already removed the board out of the laptop. Person spilled coffee on it, like she said. The only damage I see on the board is this area here. I do not know if there should be a component here. I do not know if there should be a component here. I do not have a circuit diagram for this laptop, so I do not know if we have any missing components. They may be empty by default, but I do not know. Right now I see a problematic area here. One of the pins is either burned, it's not making a connection. You can tell the pads here are good, but this one is not good. So this is probably, this pin is not making a good connection with the trace here. Let's go ahead and remove this chip. We'll try to fix this pad here. Okay, so pin number 1 is on the top right. And yes, look at that. The pin of the chip is not making a connection with this side. So we're gonna have to fix that. We can see that the first 2 pins are actually 1 pin. We'll apply a fresh layer of solder, and we need to fix the broken trace, and then we can solder that chip back on. So let's start by applying leaded solder on to those pins. I'm gonna switch to the smaller tip because now we're gonna apply the jumper wire to fix that broken trace. Okay, let's clean up. See how this flux cleans up very easy? It doesn't stick. Like I said, I do not know if there's anything missing from here. It could be like this by default. Just want to make sure those two pins are not touching. Okay, good. I'm gonna give this to Big Boss to reassemble and test. The board is back inside the laptop. Let's test to see if it powers on. Oh, look at this. The power button came on. And the light came on here. Oh, it just went off. Let's try this one more time. The power button is part of the keyboard. We do not know if the keyboard is good or not good. Look at the light. So the light is coming on and then it's going back off. A couple of things could be causing the problem. We could have missing components on the board where I showed you, or we could have a bad keyboard where water spilled on the keyboard and it's shorting out the keyboard. As soon as we turn it on, it's shorting out and then it's going back off. Or it could be the chip that we soldered back on. Maybe that chip is not good. So a lot of options. I'm gonna put this on the side for now and I'll look into it later. I have a lot of other things to get done. So we did not get this laptop to fully work yet, but we'll see. Worst case, we will have to buy the customer another motherboard. We do not have any circuit diagrams for this board, so I do not know how this board works, but based on physical inspection, we can see that the chip had a broken trace. We fixed that. We do not know if the chip itself is good. We do not know if the keyboard is good. We do not know if we have a missing components, so there is a lot of things in the equation. If the board is not too expensive, maybe we'll just buy another board and put it in. We're gonna have to let the customer know about what's going on and we'll take it from there.